Welcome students. Today we will start with the formal methods. First of all we will try to introduce what are formal methods and what is the importance of formal methods and what are the various concepts related with formal methods. So first of all, introduction. So informal methods allow a software engineer to create a specification that is more complete, consistent, and unambiguous as compared to conventional methods. Formal method basically uses mathematical notations to describe the properties of an information system. These mathematical notations basically belongs to discrete mathematics such as set theory and logical notations. These both notations are used to create the clear statement of facts. So we start with the importance of formal methods. Why formal methods are so much important in software engineering. So in safety critical environments, software failure can have the higher price. So to avoid this, we make use of formal methods. Severe consequences may arise due to software failure. For example, AT&T, this is the world's largest telecommunication company. There exists a bug that is called as a long distance breakdown bug due to ill-placed break statement in the code. That is, the break statement is placed at the wrong position, so it caused 1/3 of entire American network to go down for 9 hours. So this is one of the failure that has been reported, and in such situations it is essential that errors should be uncovered before software is put into operation. So to uncover those errors, we make use of formal methods. Basically, formal method reduces specification errors and serve as the basis for software that has very few errors before the customer begins to use that particular software system. Now, before talking about formal methods, first of all, we will like to talk about uh, for problems that are associated with less formal methods or conventional methods. So there are some problems such as contradictions. Contradictions are basically the set of statements that vary with each other. Second are the ambiguities. Ambiguities are those set of statements that can be understood in multiple ways. Third is vagueness. Vagueness occurs in the system due to their heaviness or bulkiness. And fourth is incompleteness, that deals with the set of statements leads to incomplete information. So the desired properties of formal specification methods are consistency, completeness, and lack of ambiguity. Before going to the concepts of formal methods, we just introduce the mathematical concepts that are used in formal methods. So the use of mathematical concepts provides smooth transition between the software engineering activities. The following mathematical concepts are used in formal methods. First is sets and constructive set specification. Second is set operators. Third one is logical operators. Fourth is sequences. So we start with sets and constructive specification. So a set is the collection of objects or elements, and it is used as the basis of formal methods. Second is enumerations. Enumerations basically deals with the cardinality also, and we try to say is that, for example, there is a set C plus of programming languages like C++, Pascal, Ada, COBOL, Java. So if I put hash before this, so that implies cardinality of this particular set. Cardinality is basically the number of elements that are present in the set. So in this particular case, we are having a set of 5 languages. So the cardinality of this particular set is equals to 5. Next is constructive set specification. So constructive set specification is preferable to enumeration because it enables concise definition of large set, as shown here with the help of an example, that for all x comma y that that are the elements of this particular set of natural numbers, or that belongs to the set of natural numbers, this pipeline, the straight lines, shows that such that x plus y is equals to 100. So this is basically a set that is the collection of those elements such that follows this particular predicate x plus y is equals to 100. Next is membership in sets. So for example, here we have taken a set of years: 1988, 1992, 1996, 2000, 2004. If I say at the very first case 2000, if I take 2000, so 2000 is basically a member of this particular set, and epsilon symbol is used to represent the membership. So 2000 belongs to this particular set, and if I say 2001, then it does not belongs to this particular set. So that symbol is epsilon, and we put a slash over that, and it becomes is not a member of. For the set operators, so these all operators will get used in your formal methods when we define the formal methods. First is set union. The union operator takes two sets and forms a set that contain all the elements in the set with duplicate eliminated. For example, here we have taken the two sets, one is A, second is B. So when I take the union of this, that is the set A and set B, I will get the result as file 1, file 2, text, compiler, new text, D2 and D3. So you can see here is one duplicate as file 2. This one duplicate as file 2, so that is not repeated again in our result A union B. That is only considered once. Next is set intersection. So intersection takes the common elements in both the sets. So here the common element is file 2, so that is the result of intersection. Next is set difference. So set difference is the difference between the two sets, and it is basically A minus B, and it is formulated as A intersection B complement. Further, the next category of operators that are used in formal methods are called as logical operators. That also deals with your discrete mathematics. Another important concept of the formal method is basically logic, that is of algebra of true and false expressions. Some of the logical operators are like or, not, implies to, and these are some of the logical operators. And in this particular case, uh, we deal with the operator that is for all, that is called as a universal quantification. And universal quantification is a way of making a statement about the elements of the set that is true for every member of the set. Universal quantification uses the symbol for all. An example of its use is that for all I comma j that belongs to the set of natural numbers such that I phi is greater than j, this implies to that I square is also greater than j square. For the sequences in formal methods, so sequences are basically represented using angle brackets. For example, the sequence will be written as Jones and Wilson. So the concatenation operator is a binary operator that forms a sequence constructed by adding its second operand to the end of the first operand. For example, the one sequence in this is 2, 3, 34 and 1, and the second sequence in this is 12, 33, 34 and 200. So we can concatenate these particular two sequences by the use of concatenation operator. Then when we get the result as 2, 3, 34, 1, 12, 33, 34 and 200. So these all mathematical concepts will get used uh, when we declare formal methods. So other operators that can be applied to the sequence are called as head. We want head, tail, front, last. So head is basically the first element of the sequence. Tail is after the first element. Okay, that means we will ignore the first element, and after the first element, what is the sequence that is left? That is the result of tail. Last is the last element of the sequence, and if you apply the front operator over this, then it will give me the elements from the starting of the sequence up to the second last element. So these what we did till now is basically the mathematical concepts that are used for in formal methods when we are declaring these particular formal methods in software engineering. So that these all the mathematical concepts that we have studied, that we have studied as sets, constructive sets, set operators, logical operators, sequences. These all will get used when we are working with formal methods. So formal method concepts. The aim of this section is to present the main concepts involved in the mathematical specification of software system. Further, to define data invariant, state, and operations for a system function. Data invariant is basically the condition that remains true throughout the execution of a particular function. For example, I declare a variable as max class size that should always be less than 30. So this is basically a data invariant condition that remains true all over the program or all over the function. Many formal languages such as OCL and JET specification uses this particular notation of states, and a system can be in one or more than one state. So the JET language defines a state as a stored data which a system accesses and alters, and operations are the actions that take place in the system. An operation is associated with two conditions. One is called as the precondition, second is called as the post condition. Precondition basically defines the circumstances in which a particular operation is valid, and post condition defines what happens when an operation has completed its action.